Get ready for cosmic chaos. Deep in space, a mind-boggling event is unfolding. Two black holes are on a crash course. Their explosive collision will unleash an unstoppable shockwave, packing a punch equivalent to millions of suns combined. Buckle up, folks, because this intergalactic boom will send ripples all the way to Earth. Fasten your seatbelts for an intergalactic countdown. On a cosmic scale, time is about to become relative. This monumental event will flash by in the blink of an eye. But let's dive into what makes this blazar bomb so explosive and why experts are convinced it's only a matter of time before disaster strikes. We'll also explore when and how these colossal black holes will unleash their fury upon the universe. This space spectacle was recently uncovered by astronomers, and we're about to uncover its secrets with you. Buckle up for a blast from the past. It's hard to believe it started way back in the late 1950s, when astronomers first spotted these mysterious quasi-stellar radio sources, or quasars, super powerful radio signals coming from places that seem to have no stars nearby. These cosmic enigmas left scientists scratching their heads, but as they dug deeper, things got even stranger. They discovered even more mind-boggling objects. Unbelievably bright quasars, unleashing a deadly barrage of X-rays and gamma rays on our telescopes, making them some of the most extreme space beacons in the universe. You won't believe what scientists finally figured out in the 80s. Those baffling quasars were actually galactic nuclei with supermassive black holes that act like cosmic vacuum cleaners, devouring everything in their reach. Now, when we peer at some quasars, it's like catching a glimpse of them from the side, and all we get are faint radio waves from their accretion disk. Imagine a superheated meal being served to the black hole. But then there are these incredible blazars. We're lucky enough to look straight at them from above, and what do we see? The black hole's powerful jet shooting out intense X-rays and gamma rays directly our way. Talk about an extreme cosmic light show. Imagine if a quasar as fierce as a nuclear reactor went off right here at the heart of our own galaxy, the Milky Way. Life on Earth would be in for a real shock, with ozone layers gone, and potentially even our very existence hanging by a thread. But here's the amazing part: astronomers are looking at one of these blazars, and guess what? It's been quietly chilling 9 billion light years away from us, without posing any danger to Earth. So, what makes this particular time bomb so special? Scientists only just discovered it in 2020, one after decades of watching it. Talk about a cosmic surprise. Blazars usually act like unpredictable strobe lights because supermassive black holes inside them gobble up matter inconsistently. Think of a flickering neon sign that's about to burn out. But this mysterious blazar has got everyone stumped. Since its light turns on and off in a super neat rhythm, it shines every single year. Now you might think, hey, maybe there's someone giving it a regular snack. Unfortunately, it's not quite that exciting. Pulsars are the only cosmic objects known to follow such precise patterns, but they do so at lightning-fast speeds, measured in tiny fractions of a second. What could be behind this blazar's unique and mysterious one-year cycle? But here's the thing: blazars aren't pulsars, and they're powered by massive black holes, not tiny neutron stars. As for quasars, those super powerful space lighthouses, one was spotted showing a similar rhythm, but it was just a one-time flash. Now let's head to the OJ 287 galaxy, where we find an epic cosmic dance happening. A black hole weighing 100 million suns is crashing through the disk surrounding another monster that's a whopping 18 billion times heavier. This dramatic encounter unleashes incredible explosions and might be responsible for the blazar's precise ticking pattern. But here's where things get even more mind-blowing. Those flashes aren't always predictable. Sometimes it's a yearly occurrence, while other times we're waiting months, even years, for the next one. Scientists think they know why. They believe our blazar is powered by two black holes in an extremely unusual, super stretchy dance around each other. As far as astronomers have discovered, this OJ 287 galaxy duo is the only pair of its kind known to science. Initially, scientists thought it was just another quasar pair, but when they looked closer, they realized that those regular flashes couldn't be explained by the usual suspects: accretion disk explosions. So what's really making our blazar tick like clockwork? Astronomers went through all sorts of possibilities before landing on an idea that's just wild. Imagine a super powerful spotlight blasting directly at you, only instead of being steady, it swings back and forth like a pendulum. Each time the beam hits you, it's almost blindingly bright, but when it moves away, relief washes over you. In our Blazar, this spotlight is actually an incredibly intense beam of energy that shoots out from one black hole as it zips around its partner in their bizarre dance. The key to understanding this ticking pattern lies in the way this beam shifts and changes direction, creating those regular flashes we see from millions of light years away. So, what sets off this crazy cosmic dance? It turns out it's a special pass to Dix with another behemoth, a second supermassive black hole of similar enormity. But here's the catch: this partner has to be seriously close, about 100 times nearer than our suspected Blazar duo OJ287. To put this into perspective, if we superimpose this system onto our own solar neighborhood, that outer black hole would basically hang out at the boundary of our heliosphere, just 2,000 astronomical units away, and the central Blazar, it'd be zipping past Mars like it's a cosmic comet. Hold on to your seat. These two gargantuan supermassive black holes have been hurtling towards each other for an astonishing 100 million years and are now just 1% away from their cosmic collision course. Scientists tracking this doomsday event, which we've learned about thanks to LIGO's ultra-sensitive Blazar observatories, warn that the aftermath will be nothing short of universal chaos. So buckle up, folks, as we're in for a wild ride. You might recall how LIGO rocked our world in 2015 by detecting gravitational waves from two behemoth black holes colliding, each packing as much weight as 30 suns. When they merged, a minuscule 3 solar masses were released as part of the immense shockwave that zoomed past Earth at the speed of light without us even flinching. But here's the deal: this cosmic crash was a relatively small-scale affair, and all it managed to do was cause space to slightly expand and contract on an infinitesimally tiny scale, smaller than even the tiniest atoms. Fast forward to our Blazar bomb scenario. With black holes closing in for what promises to be a catastrophic collision, we're looking at an entirely unprecedented shockwave of unimaginable might, one that could drastically alter the fabric of space itself. Now, buckle up, because we're about to dive into what could possibly happen when at least 10 million suns worth of energy is released as gravitational waves. Imagine space-time tears so massive they can rip atoms apart. That's what we're talking here. With this unfathomable shockwave, would it be enough to briefly pause the nuclear reactions driving our own sun, or might it even break the bonds holding atoms together and leave Earth in a catastrophic disintegrated state? Or maybe, just maybe, it'll be like that mind-bending tablecloth trick when you suddenly pull the floor out from under your dinner plates, leaving them suspended in midair. The possibilities are endless, and the implications are mind-boggling. Here's where things get really intriguing. Will everything just stay put, or will a shockwave of this magnitude send our reality into chaos? Think about it. LIGO has already detected super-weak gravitational waves millions of times fainter than what we're talking about. So, until scientists can pinpoint the exact mass of those black holes and track down their sneaky, weak gravitational waves as they get closer, we just won't know for sure. But one thing's for certain: astronomers are hyped up, and they're ready to dig in and uncover the secrets of this cosmic Blazar bomb. Here's a mind-blowing perspective. This Blazar bomb has an explosive countdown of just 10,000 years, which is basically just a tiny blink in the grand tapestry of our universe's existence, equivalent to milliseconds on your wristwatch. But don't let that fool you. As it happens, this Blazar is a whopping 9 billion light-years away, which means those two black holes have already made contact and sent shockwaves rippling through space long before Earth even existed. So, with the Blazar bomb's gravitational wave now just 10,000 light-years from our own Milky Way, we're essentially looking at an intergalactic time bomb that could impact our cosmic neighborhood in a major way. The million-dollar question is, do we have enough time to send out exploratory probes to gather more intel on this cosmic bombshell before it's too late? Let's face it, with the Blazar bomb hurtling towards our neighborhood at incredible speed, the clock is ticking, and our window of opportunity might be smaller than we think. But hey, as the saying goes, when life gives you lemons, make lemonade. Maybe this cosmic alarm bell will actually serve as a wake-up call for us to accelerate our space exploration efforts and get